2 years ago, physicists detected for the first time the infinitesimal ripples in space itself set off when two black holes whirled into each other. The observation of such gravitational waves fulfilled a century-old prediction from Albert Einstein and opened up a whole new way to explore the heavens. Today, 3 leaders of the massive experiment that made the discovery received the Nobel Prize in Physics. Rainer Weiss, 85, of the Massachusetts Institute of Technology, MIT, in Cambridge, and Kip Thorne, 77, of the California Institute of Technology, Caltech, in Pasadena hatched plans for the Laser Interferometer Gravitational Wave Observatory, LIGO, in 1984. Barry Barish, a Caltech particle physicist, later guided the construction of the twin LIGO observatories in Hanford, Washington, and Livingston, Louisiana. The trio will share the $1.1 million prize. LIGO's third founder, Ronald Drever, died in Edinburgh on 7 March at age 85. Nobel Prizes are not awarded posthumously. Other physicists rate the discovery of gravitational waves among the most important ever in physics. It's revolutionary, says Abraham Loeb, a theorist at Harvard University. It's very rare that we open a completely new window on the universe. Weiss, however, says that he finds the prize somewhat embarrassing. Receiving money for something that was a pleasure to begin with is a little outrageous, he says. The best way I can think of it is we're symbols for the much bigger group of people who made LIGO happen. Weiss says he has arranged to donate the prize money to MIT to help support students. The entire notion of gravitational waves is mind-bending. In 1915, Albert Einstein explained in his general theory of relativity that gravity comes about when mass and energy warp space-time, causing freely falling objects to follow curving trajectories. A year later he predicted that a twirling barbell-shaped arrangement of mass, such as 2 spiraling black holes, should radiate ripples in space that would zip through the universe at light speed. Detecting the incredibly feeble waves is a challenge. Each of LIGO's L-shaped interferometers acts like a pair of perpendicular rulers. A passing gravitational wave will generally stretch the 2 4-kilometer-long arms by different amounts, and by comparing laser light bouncing back and forth in the arms, physicists can detect that slight differential stretching. LIGO's interferometers can detect a difference in length as small as 1/10,000th the width of a proton. Weiss, a consummate tinkerer who once flunked out of college, wasn't the first person to think of using an interferometer to try to detect gravitational waves. In the 1960s, U.S. physicist Robert Forward built a small interferometer for the task. However, Weiss analyzed the problem far more thoroughly and recognized the need for kilometers-long interferometers. He also identified the main sources of extraneous noise, and explained how to deal with them in an unpublished report in 1972 that became the basis for LIGO.